Okay, so let's do this. Wrap things up. Let's take 5 minutes, we'll come back. We carry on here. So quick 5 minutes. I'll be there. Hold on. Hold your horses there. So again, 5 minutes. Tell me.
Oh, okay, never mind. Sorry. Professor, could you confirm?
Yes, I'll jump. You know what? Put in the two string. Make it work in the two string and show me. It's working? You got it?
I see your solution.
Yes.
Your solution is not good enough.
Okay, great. So if you have a better one, I'm happy to redo mine, you know? Nothing wrong with that. What's up? What's my solution? To be honest, I did this a year ago. I don't remember. Maybe I improved things, you know? What's up?
Professor, why did you use premium? I want to change my protected without premium.
You want to change your protected without premium. Without premium. Okay. What is premium? I don't even remember what is premium.
Premium, it's something that here is 0, but when you go to the mapped photo,
Yep.
it's changed to 10, and the frame at 25.
It's just a constant that.
Why I cannot directly change the price?
Let's go there to the photo. So protected price. Let's see here. Okay, price change here. See set price. And then I'm calling. See, that's what I'm trying to get you to understand. Is that you calculate the price whenever you change the height. See, you calculate price. Whenever you change the width, you calculate price. Then in the frame one, let's see, yeah, we don't even need anything with them here, see? Whenever we make a change to the width or the height, we calculate the price again. So I'm creating a method here that is private. Whenever height gets changed, gets set, and width gets set, I will calculate the price.
I got this one.
Got it?
But why I have to declare the third party like premium?
Okay, you don't. This was just one way that I came to solve that. You can now. What I recommend is that, however you do it, still use the set for height and the set for width as your trigger. Because here's the key. The key is to find what's the trigger. When is that the price will get calculated? What's the trigger of that? What will trigger the price calculation? What is it? What needs to happen for the price to be changed? What is it? When you change the height or the width. When you change them, you need to recalculate the price. Right there. Calculate. It's a trigger. Do you get what is trigger? What
Change
is
the price.
Yeah, but what will trigger the price change? It's when you set the width and you set the height. Or one way. You with a calculated thing, you have to think, when is it that I need to change this? What is the trigger? What needs to happen for the price to change? Well, when the width change or the height change. That's when I need to recalculate.
Got this one. One general question.
Okay.
When I have one protected in my parent,
Yep.
can I change it directly from the child class?
Yes. Yes. You can.
I don't need the override. I don't need
No.
new.
No, because we are talking about protected fields, correct?
Protected integer for protected string.
Yeah, so you don't override a variable. You override a method, you override a property, but you don't override a value. You just write a new value. You just put a new value right there. Just put a new value. You don't redefine that. You don't need to redefine because it's protected there. I have access here.
And they have a same memory location for both of them.
Yes,
Yes.
yes.
And they behave like a references.
Correct. Okay?
Professor, sorry to bother you.
No problem. Anytime. Time.
I just have some questions here. So I'm not, I'm confused about why do I have to call set price here at the setter for height?
Yeah, because however you want to solve that, the question that you have to ask yourself is this: when the price gets recalculated, what happens? What happens that will trigger the price recalculation? What happens?
Width or height is
Change,
right?
So that's what you see there. Now, if you make that as a method, I did that as a method, so I don't need to write the rules again and again on both of them. I can just call set price. I can call set price. I can call set price from both of them. I don't need to.
Oh, okay.
Okay. So when the weights change, I recalculate. When the height change, I recalculate. Because those are the two variables that the price depends on.
Okay.
You got it?
Got it.
But again, there are other ways to solve that, okay?
And also here, so the price here, the code.
See, what you're doing here is also right, because, see, you are recalculating when someone tries to get the price. That's okay. That's okay.
But the problem is, for the child class, I can get it right here.
Because it's not this, it's the base one. I mean, you're
So base here. So base.
oh, okay. So math. Okay, so
Yeah,
this is the math for the math. Okay, so you just say price, capital P here.
But it's read only.
Okay, so then
No setter here.
go back there. So price is read only. Okay, so what about this lowercase price? How is it? How is it defined? It's there. Go there.
So it's protected. So.
Okay, so you have access then.
But the problem is it doesn't work. So it's still 9.99. It should be 19.99.
Okay, so go back there. Okay. Scroll down. Go to my solution there. Oh, but you did this in the constructor. You don't do this in the constructor.
Oh.
The constructor happens once only when you create the object. The prices are not set yet. This.
Oh.
Okay. This happens only once. The price is not even there yet.
Okay. Yeah.
Okay.
So instead of you writing in the constructor, I can perhaps override property. Like
Now is where I would have a look at my solution to have a look at what I did there.
okay.
So, again, I don't remember, to be quite
Yeah,
honest.
you set you have a constant. Yeah, constants.
Called premium.
Yeah, and you set the constants in the parent class to 0, and
I redefined them.
and yeah,
Well, that's one way.
yeah. Okay. So, I just want to figure out why.
Yeah, but again, this only runs once. When you create the object, the price is not even set yet.
But can I create a property here? So, price.
Well, now you have to explore that. Explore that a little bit more with my solution as a base.
Okay.
And you even have my explanation there. So have a look at my explanation there. To be quite honest, I don't remember my own explanation there. Okay? Anyone else?
Yeah, like he said it with like the group.
We will fix the group. I remember you. Even if it's the last thing that I do today before I die, I'll fix the group for you. You got a question? What's the question?
My friend Daniel,
Yeah.
he has not submitted the quiz. So like he called me up and he asked me about the deadline for this quiz.
Well, 10 minutes ago. 10 minutes ago.
Like now he can't complete it.
Well, he calls me. He gonna tell me that after the quiz. Why he didn't tell me that before the quiz? Okay. One tiny question. When I have a tiny moment, I'll answer a tiny question. What's up? Not yet. Not yet, because I have more sections that will do them, but I will release the answers by, most likely by Monday, okay? Yes. Yes. Okay? Not anymore. Not anymore. But I will give you the answers for sure. Okay? Yes. When I have a minute, I need to progress with the content, okay? Okay, so let's keep progressing here. Great, so I would like us to have a look at this video here. It will talk a little bit about polymorphism. Okay, so let's continue with that one.
Second, we have a class called animal. Let's actually just say for a second we have a class called animal. And let's say we have a class called dog.
Guys, let's focus here for a second.
And let's say we have a class called dog. And dog extends animal. And we have a class called cat, and cat.
So when he says extends, we should read that dog inherits from animal, okay?
Extends animal. And we have a class called turtle. Turtle extends animal. Right? You can see where this is going. You can have this base animal class, like our base particle class, and lots of subclasses that have all the basic functionality and data of an animal, but with their own customization. Now what we want to do is make an array. In our particle system example, we're going to use array lists, but just for thinking it through right now, let's use a plain old array. We're going to make an animal array called kingdom. Kingdom, which is a new animal array, and we're going to have 1,000 animals in it. Okay? I want to put dogs and cats and turtles into that array. Can I do that? The answer, of course, is yes, otherwise why would we be here? But just think back to, would that have been your first instinct? Maybe you would have said, I'm making a processing sketch and I have all these different objects on the screen. I need my dog array to keep track of all my dogs. I need my cat array to keep track of all my cats. I need my turtle array to keep track of all my turtles. This is going to get unwieldy pretty fast. In some cases, you might want that, but one of the reasons for doing this inheritance structure is it allows us to kind of collect all of these objects that have the same parents together and work with them together. This is polymorphism.
Okay, so I'm just going to pause for a second and, in a way, restate what he says there. His example, he's creating an array of animals. And because animal is parent of cat, dog, and turtle, we can, in that array, we can add dogs, add cats, add turtles, and work with them as they were the same type. Okay, so that's, as he says, that's what polymorphism is. We collect a bunch of similar classes that have the same parents, and we can work through them together as they were pretty much the same type. Yeah.
So it is relationship between classes?
It is?
So polymorphism, it is relationship between classes, right?
Not just that, because we have other types of relationships that are between classes that are not polymorphism. Let's say I'm a person, I have an address. Maybe address is a different class. So address is not inherited from me, that is a person. But I have a person in my profile. Sorry, I have an address in my profile. So again, we can have a relationship with other classes, but not necessarily in a polymorphic way, in a parent and child relationship.
So it could be also methods, right?
Well, methods, again, method is an example of a polymorphic behavior. Like we have in this animal example, we can have move. So a bird will fly, a fish will swim, a human will walk. So again, we have move on all three of them, but the behavior of each one is slightly different. So again, this is also an example of polymorphism. The same method assuming different implementations. Make sense? Okay.
Polymorphism is going to allow us to put all these different kinds of animals into the same generic array of animal objects. Array of generic animal objects. So let's look at 2 lines of code that I'm going to write out for you here. I'm going to say dog rover equals new dog. Okay. This is something we should be very comfortable with. We're very comfortable saying, I have an object of type dog, its name is rover, it's a new dog object. Great. Here is polymorphism, something new that we're allowed to do. Animal spot equals new dog. This is polymorphism. What polymorphism, which means from the Greek, many forms, what it allows us to do is say, I have a dog object. And if it's convenient for me to think of it as a dog object, I'm happy to do so. If it's more convenient for me to think of it as an animal object, that's also allowed. I mean, it really truly is a dog. A dog is a dog is a dog is a dog. But we can talk about it as if it's an animal, because a dog is an animal. It's a child class. The dog is made from a child class of animal. We can make an animal object which is specifically a dog. This is what allows us to put kingdom index 0, for example, could be a new dog. Kingdom index 1 could be a new cat. This is the magic of polymorphism. Kingdom is just a bunch of animals. A dog is an animal, a cat is an animal. We can collect all these different kinds of classes into the same array. Great, right? Okay, so hopefully this makes sense to you, but there's one little piece of this that I think would be worth mapping out. What happens when we loop through that array? Right? And we know now, by the way, that we have this new kind of loop that we can do. We can say for every animal A in the kingdom array.
So he's using a more Java-oriented syntax, okay? So we have to adapt that to, you can use a for each animal A in this array, okay? So that's the only time that he's using something very specific to Java, but we just have to reframe that. What he's gonna do is he's gonna loop through the array, and he's gonna call animal.sleep, animal.eat, and again, if it's a turtle, it will eat like a turtle, it will sleep like a turtle. If it's a cat, again. So we can work in the group at the same time, even though they are different types of objects, but they have the same parent.
I could say, and what do our animals have? They had a sleep function and an eat function. I could say a.sleep, a.eat. So I could still loop through all of the animals, and when it gets to each one, I don't have to say, if it's a dog, sleep like a dog. If it's a cat, sleep like a cat. The magic of polymorphism and inheritance is it just knows how to do it. It knows, like, we made a dog and put it in the first spot. We made a cat and put it in the first spot. They're both animals, but a dog is a dog is a dog is a dog. When it gets to sleep, it's going to sleep like a dog. When it gets to eat, it's going to eat like a dog. So this is very powerful. We can have an array of generic animals. We can put specific kinds of animals in that array. We can loop through all of them, and we don't have to keep track of which one is which. Java /processing/ the computer, the little people inside the computer pulling in all the switches and buttons in there. It keeps track of all of that for us. This is incredibly powerful. It's going to allow us to make a particle system full of particles where...
Now, he's going to talk about something very specific there, so that's enough for him. But again, that's this ability that we have now to work from a parent to work with specific children, with specific classes. Yep, go ahead.
What is
Spot? It's just a name of the object. It's just a name. I could say animal 1, animal 2, animal 3. He says Spock.
what for do we need a spot? I mean, he didn't use it in the...
No, he just gave an example of how to create a Spock. I mean, Is this clear? Okay.
Professor,
Yep.
it means that with polymorphism,
Yep.
with one superclass, I can create a lot of objects from subclasses.
You can create subclasses and you can declare a superclass. You can declare an object of a superclass, and from that you can create specific objects. Specific objects from specific classes, from subclasses of that parent. Subclasses, yes.
So one parent class create object from subclasses.
Yeah, not that the parent is creating that. I mean, we are creating the subclass object and assigning that to the parent class.
What's the point of this one when we compare to the one subclass create subclass?
Because now, as he is demonstrating here, we can bring that to a collection. So that's one example. We can bring that to an entire collection instead of having to work with a collection of dogs, with a collection of cats, with a collection of turtles. We can work with a collection of animals and loop through them and do whatever we want to do with them collectively. We don't need to deal with them individually because they share sleep, the name sleep, they share the name eat, they share the method. The actual implementation is different for each one of them, but they share the same terminology across them, so we can call sleep, and as he says, if it's a dog, it will sleep like a dog. If it's a cat, it will sleep like a cat. Okay?
Professor, in this looking,
Yep.
animal A.
Mm-hmm.
Now for the first time, dog sleep, dog eat, then let's go to cat. Cat sleep, cat eat.
Yes. Yes. So if index 10 is a cat, then it will call sleep of the cat, eat of the cat. If it's a dog, it will call the specific one. That's an example, yet another example of polymorphism, assuming different
I didn't get
forms.
how
Yeah.
it's going to go from dog to cat, for example.
So, do you understand the concept of an array? So we have an array with, in this case here, 1,000 positions. Okay, so he declared here at the very top, 1,000. Okay. So somewhere in the codes, cats have been created and added to this array. Dogs were created and added to this array, like he's doing here. Kingdom, he's doing index 0, it's a new dog, index 1, it's a new cat.
Okay.
Okay? So then it's, now, again, he's hardly coding that.
It's an instance of the class dog.
Yes, yes,
And this one's an instance of the class cat.
yes, yes.
Sure. But finally, we have to just like define that implementation for each dog and cat.
Yeah, we have to, in their own classes, we have to implement them. Yes, correct. You're correct.
And then they can just know how to, the cat how to sleep.
Yes.
Dog how to eat.
What happens there? What happens when you call that method? Something happens that most likely is different from a cat to a dog to a turtle. Okay?
So, but we can use like most of them, cat and bird, we can use the name of the parent class.
Yes, because they share the same parent and the same name of those methods.
Yeah.
It's shared by the parent as well.
So can I think like that? They have the same type of the.
They have the same parents. They don't have the same type. They have the same parents. They have animals that their parents.
But like the dog sleep and the cat sleep, they have the same type of the, like they are.
They have the same parents. Yeah, they have the same ancestral. The same, yes, yes.
Professor, it's mostly used inside the loop.
Well,
A here the index?
what is that?
Animal A, is it the index?
A, in the loop, it goes through item by item in the array.
Like, so the index is like 0, 1.
Yeah, so A is the item, the object in that index. Yes,
In that index it says 0.
1, 2, every time it goes through the loop. So again, I missed the point.
It is mostly used
Inside loops. You know, early on today, we went through that get greeting, which is an example of polymorphism as well. We can send an employee, we can send a commissioned employee. That's polymorphism too, and it's not in a loop. Okay. Now, if this was not already complicated, it's going to get more complicated. Yay! Okay, Let's talk about something that is not complicated, at least for now. Concrete classes. Who knows what is a concrete class? Yes. No. Anybody else? What is that?
Every day we use it.
Well,
Not every day, that we used it until now.
actually, but let's bring this back to coding. The class that we have worked so far, all classes, employee, commission employee, they are all concrete classes because we can instantiate an object from that class. This is what it means to be a concrete class. I can say employee E equals to new employee. I can instantiate that. This means that this employee class is a concrete class. Now, yes. The base class of what?
We can instantiate it from the base class, derived class, right?
So let's talk about employee. Again, bring the base class that you were talking about to an employee. What is the base class there?
Employee is the base class, and from employee we can inherit.
And the base class of employee is objects. This is way simpler. Again, concrete class is all classes that we have been working so far. All of them are concrete classes because all of them we can create instances of that class.
What's the difference between base class and concrete class?
And
Concrete class.
base class is the inheritance. It's the inherited class. It's the parent class.
And from concrete class we can also inherit, no?
Okay, concrete class has nothing to do with inheritance. Nothing to do. Concrete class, again, is just that, a class that we can instantiate. That's it. No parent, no child. Again, it doesn't matter if they, actually, to be quite honest, every single class that you're going to be using, it's a child, at least of who? Of objects. So again, so concrete class means it's a class that you can declare an object and you can instantiate. Now, why am I bringing this now? Because we're going to talk about the opposite of concrete class.
So object class is not the concrete class?
The object class?
Yes, it is.
Well, you can instantiate. I mean, we don't use that too often, the object class itself, but you can.
So it is concrete class as well.
Yes, it is. Okay, so again, the reason why I brought concrete class is because we have the other type of class, which is an abstract class. In abstract class, we don't instantiate objects from that class. We declare the class, but we don't create anything from it.
You see it again?
What would be the natural question then? What's the point? What's the point? Isn't it? What's the point of an abstract class? I can tell you this. Again, just so you can grasp a little bit about that. If I tell you, draw a shape.
What shape?
You may ask which shape, or you may go ahead and draw whatever shape, isn't it? But if I ask as well, draw an animal. What could be the question? Which animal? I would say, which shape, which animal? The point is this. In abstract class, it's just a general definition of what the children of that class would look like. If I say animal dot move, I'm just saying that animals can move, but the actual implementation of that move, how it's going to move, it's done not in the abstract class, but in the children, which can be, should be, concrete classes. I can say animal, let's think about some other, let's move away a little bit from animal here, and let's think about shape. Shape, let's think that we are drawing shapes that will have corners. So maybe the shape, the abstract class shape, will have number of corners. And then for different implementations like a triangle and some other circle would not have a corner, but that's okay. then those specific classes, they would have specific implementations. So it's like the abstract class is just a concept. It's just an idea that you're going to actually perform the implementation in the children, but they inherit all from this abstraction.
So the abstract becomes the base.
Yes.
And the
The
children
yes.
specify what's in the abstract.
Yes. The children will perform the concrete implementation. Now, there are a few caveats with that. I have a few examples here. Just mention that. The caveat is that abstract classes can have abstract methods as well. Like what I said, in animal we have move. Move will not be implemented there. But maybe we have other methods that could be implemented there. Let's say that, we are in a pet shop, in a pet store. And yes, different animals will have different behaviors, but they all have a price. They all have, some other things that are common to them. So the abstract class can have concrete methods as well, concrete implementation as well. It's not only so abstract classes will not only have generic abstract methods, but they can have as well real implementation there, okay? Now, again, because it's abstract, we cannot do one thing that the concrete class can do. Concrete class, we can instantiate objects. Abstract classes, we cannot instantiate objects from them. We can inherit from them, but we cannot say new animal, because animal, in our case here, it's an abstract class. I'm just going to show a few more examples of potential abstractions. When I say artist, again, we may have different implementations of artists, sculptor, painter, illustrator, singer, dancer, whatever it is. Okay? We may have common attributes there, and we may have specific ones here. If we go back to our person example and students and professor, well, maybe person doesn't need to be abstract because, we can have a person. It's not just a concept. It can be a real thing, But again, abstract classes, the abstract class is just a general concept, okay? That may or may not have real implementation. Musical instrument, if I say instrument is the parent, well, it's pretty much an abstraction because I don't have the details of that instrument yet. I'm going to have the details right here. I have some general information, material, type, manufacture date, some abstract methods as well. How to play, how to clean, how to tune the instrument, okay? And again, we are tired of looking at the animal here. At least we have a few different animals there.
Professor,
Yep.
if superclass is the abstract, all of the subclass must be abstract or not?
If the superclass abstract, the subclasses, no, the subclasses can be abstract, but they don't have to. They can be concrete as well.
It wouldn't make sense for them to be abstract.
We can have more abstractions as well. We can have multiple levels of abstraction. That's possible. In our case here, we're going to be working pretty much with one abstraction and then concrete underneath it. But we can have multiple levels of abstractions.
Like subclasses that are abstract.
Yes, that are abstract. We cannot, but then, again,
You can inherit them.
yes.
But that makes it more
Mind blowing, mind bending. Yes, I get it. Yes.
The only difference between abstract and inheritance class is that from abstract, I cannot make the new object.
In an abstract class, you cannot create a new object. No, you cannot. But from a child of that abstract class, you can, if it's a concrete class. Okay? Just want to show a few examples here. Let's see this animal class here. Actually, I think I have it here already. Okay, so here we have the application, we have an abstraction called animal, and inherited called dog, and inherited called cat. Let's have a look at animal first. So animal has a private field. Look at this. What is this? Is this a method? Is it a property? It's what? A constructor. Okay? Now, look. This is an abstract class, but I have a concrete constructor. As I said, abstract classes can have concrete members, like constructors, like methods, like properties. But it also can have abstract methods. In an abstract method, let's look at how it's built. We have the keyword abstract, and then we don't have the body of the methods. Body is this part. Is what it's inside the curly braces, okay? So we just finished with a semicolon at the end, that's it. This means that this is an abstract method that is not implemented here. What is the note, the point that I want to make? When you define a child class of animal, now you have to implement the abstract methods that you specified in the parent. So if I go to the dog animal, I'm going to say make noise, and I will have to implement that. I'm going to have to use the keyword override, because here we have abstract. Now again, it's another use of the override keyword. Override is not only used with virtual, but also together with abstract, okay? And here we have the true implementation of make noise for a dog. And we have something similar to the cat. We have make noise to the cat.
This make noise is still behave like the abstract, or you can make the object?
Well, the abstract doesn't behave at all. There's no implementation in the abstract. So again, the abstraction is not doing anything. Now, the abstract class, when it flags a method as abstract, it's demanding that any child from that class, abstract class, will have to implement that method. What is that? Well, but virtual does not, the parent is not demanding that the child re-implement it. It's not demanding that. It's just making it possible to overwrite. It's a possibility, not mandatory. Yep, no.
So this is mandatory.
I'll give, look at this. I'm going to get rid of make noise here. Let's wait for a second, see? Dog does not implement inherited abstract member make noise. So it doesn't even compile. Okay? That's how the abstracted classes can, again, I'm going to use the word, demand from the children that they have to implement that method. If they don't, again, you're not even able to compile the application.
So now to make an instance,
Let's just finish here. Go ahead.
make an instance of the dog inside the main method. Can you say then animal of let's say Rottweiler equals new dog.
Yep.
So that makes the instance of the dog.
Yes. Yeah. 1 second. Andre? Yeah. Andre. Question?
Not inherit, if we don't have abstract method, then we cannot inherit the class.
If the parent, which is abstract, has an abstract method, and you don't want to implement that, you cannot inherit.
Doesn't have an abstract method, then it cannot be inherited
No.
from the parent.
The child, okay, so the child will not have an abstract method. It will have a concrete one
Yeah.
of that name.
But you said that if it doesn't have an abstract method, it will not compile.
No, what I'm saying is that the child, if it does not override the abstract method, it will not compile. And I'm going to show it right now. I'm going to get rid of this. Wait for a second.
So now from animal.
Correct. 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 Yes.
So what about the cat one?
1 second. Let me just get there.
Can you create an abstract method to a concrete class?
No. Abstracts, that's a good point. Abstract methods can only be available in abstract classes. Now, abstract classes can have concrete methods. But again, abstract methods cannot be part of a concrete class. They have to be part of an abstract class.
So abstract methods has to be inside
Abstract classes. But abstract classes can also have concrete, non-abstract methods. Okay, concrete methods. Okay.
When we use the abstract method in the abstract class, so we use it for demand the children class for putting the arguments into my method. That's what we use it for.
It demands implementation.
Yeah, just we demands the children class.
Implement. Yeah, address that. Okay, you had a question?
For every class inheriting from an abstract class.
Yeah.
Because it has to do with the public, from the public abstract method. So now every class inheriting from that abstract class have to create a method that is developing that abstract into the
Making it concrete. Making it concrete. Yes.
So now if I create a class cat,
Yep.
I have to do the same thing again that I did for the dog.
Yeah. Hopefully it's not the same thing. Hopefully they have different. Yes.
Different nodes, but I have to always create
A body.
the
Yes.
noise part
Yes.
from the abstract
Yes.
to make it to make
Compatible.
it
To make it compatible. To make it compile. To make it compatible. Okay. It's how the parents again define some constraints to say, hey, do you want to be my children? Okay, you better implement this. Okay?
Professor, the abstract method, it is only the purpose for use that is to ask the subclass to define some value for that method.
To define some behavior for that method. Yeah, yeah. It's saying that, hey, I'm promising that to anyone out there that if you get a child of mine, they're gonna have this make noise done. I'm promised to everybody. I can guarantee that if there's a child of mine, they're gonna make noise. Well, I know that child make noise, yes.
I think that the only difference between abstract and virtual already have some value. We can change it with override.
Yes.
Abstract doesn't have any value. I give the value for the first sentence.
You can think about that way. But now again, virtual is not a contract. I mean, I'm not demanding my children to implement that. It's optional. Because I can use the implementation of the parents. But in abstract methods from the parents, I have to implement it. Okay?
Is it like the most of use we create the abstract class for demanding the children class for implementing?
Abstract class is a way to aggregate general information about a particular type of class, a particular, like animals, like, again, music instruments. We're gonna see a few more in the examples, okay? Awesome, okay. Okay, so let's see here, implementation. Okay, and then to wrap things up, let's talk a little bit about interfaces. Again, last topic, just to wrap things up. In a way, it's even simpler than abstract methods, abstract classes. You can think of interfaces as a complete abstract, I won't call it class. It's interface. Interface is a category of its own. Let me just step back here for a second. The concept of multiple inheritance in C#, it's not really fully applicable. In C#, a class can only inherit from one other class, whether it's abstract class or concrete class, but only from one single parent class. However, the way that C# simulates multiple inheritance in a way is by using interfaces. Because with interfaces, I can have a child inheriting from multiple interfaces. Now, what is interface?
Before you continue, I
Yes.
have one question.
Sure.
It's back on the dog and the cat.
Yes.
So we already created dog.
Yes.
Now what if I make cat inherit from dog, even though it's logically not
Got it? What's your question?
So if I do that, then I don't have to recreate the method of make noise anymore because that's already in dog.
Yep, it's already implemented there. Correct. Correct. Yep. You can redefine,
Yeah.
and by the redefine you can use override,
Yeah. Okay.
but again you don't have to. Okay. Okay. So what is interface? Let me show you this. First, I just want to quickly differentiate between abstract and interface. They are similar, but interfaces, all their methods, properties, they are all abstract. Interface cannot have concrete methods at all, only abstractions. Now, to make it a little bit more complicated, is that it does not use the keyword abstract at all. We call methods of interfaces as abstract because they don't have body. However, they don't have to use, actually they don't use the keyword abstract at all. Interfaces, all members are all abstracts. There's no implementation there, okay? Now, it still has the same obligation as with abstraction. In an abstract class that has an abstract method, if we have a children, it has to implement that abstract method. In interface, that's the same thing. If I have an interface that has a method called, I don't know, make payment, the children of that interface, they have to implement make payments. Now, to me, this is what truly differentiates the concept of abstract classes and interface, is that interface doesn't have a relationship very clear of parent and child. I'll see if there's an example here. Yeah, iWorkable. iWorkable is a typical interface. It has a method which is abstract.
So automatically the method is abstract. We don't even have to.
We don't even have to use abstract. Yeah, correct. Correct. We don't even have to. So again, as you can see, we don't even have abstract here, but it's an abstract method. If a class inherits from iWorkable, I have to provide an implementation for work. Okay? Now, again, that's why I like this definition here. Interface, it is used to implement peripheral abilities of a class. The keyword here is peripheral, which, actually let me make this bold and underline. And before I have defined it here, which I skipped, core. See, that's the true conceptual difference between abstract classes and inherited, and, interfaces. Abstract class, we're talking about a core class. A cat is an animal. There's a clear parent and child relationship because I can say, cat is an animal, dog is an animal. But when it comes to interface, I cannot, it doesn't make sense to say a cat or a person is iWorkable. It does not make sense because when we use interface, we are adding, it's almost like we have a class and we want to add more functionality to this class. So we inherit from an interface and we add some additional, and by peripheral, it means that it's additional features around it, but it's not the core of the class. It's not the core. It's just, we are just adding features to this by and that's the reason why we can do multiple inheritance with interface. You can say a cat inherits from animal, comma, I workable, comma, I sellable, comma, whatever it is. You can keep add that. Only one class, but as many interfaces as you want, as it makes sense.
Add multiple
Inheritance.
inheritances.
Kind of. It's a way.
It doesn't have to be the parent and children, like the relationship.
It still has a kind of a parent and child relationship, but it's more of a, I mean, the same way as we use abstract classes with loops, we can use that with interfaces as well. They have similar behavior in general, but again, the keyword really is peripheral. It's more of we are adding features to the class. It's not really the core of the class. To be the core, it has to be an abstract class or a concrete class. Yes? Okay, so ask me a question.
What is the difference between these interfaces and inheritance from another class?
From an abstract class, for instance. Interface is just a set of method signatures that have no implementation. They are all abstract. So an interface is more of a, again, this tells a lot. If you can try to digest this slide, this one single line, we are adding, and once we see some examples, that will hopefully become a little bit clear. Let me see if this one, look, iWorkable is a very simple interface. It has one method called work. So animal, do some work, I don't know, drag my shoes or whatever. Now, look at this. I'll zoom in here. Look, employee is an iWorkable. It inherits from iWorkable. Because of that, I have to implement work. Work for employee is I do my job. However, look, employee and animal, what employee and animal have in common? Well, they both inherit from iWorkable, which means both of them have to implement work, do the work methods. But again, employee work like that. The abstract animal, well, we are inheriting the abstract class. We can create an implementation here, but we can also define work as abstract here so that the dog and the cat can do some work here. Now, here's how the dog does his work. The cat does her or his work. So again, we are just adding one little feature to the classes there. Just this do work. Now, all of them, they all do work. So I can very much start a loop that goes through animals, through cats, through employees, doing their work, because they share one common ancestor. At the end of the day, they still share this parent here.
That's a question.
Yes.
Why is the override?
Override where? Here?
Down, yeah.
Because whenever we use the keyword abstract in the parent, we have to redefine the parent by using override keywords. So you see, we have work here in the animal. It's not implemented. It's still abstract. It could have been implemented here, but the code example choice was to implement that in the dog and in the cat. So again, look at this. We cannot really say that an animal is an iWorkable, but we add iWorkable to add one extra feature to all of them, the do work. And now they share employee, dog, cats, and animal. They share work in common. They share this work in common. This allows me to loop through them and call the do work for each one of them, because again, they share the same interface. I know it's a lot for 10 o'clock, but let's start there. Andrew.
Why do we still need to define public abstract string work if we already inherit them from my work?
Why do I need to define, you mean?
Public abstract string word definition. Yeah, here, in the middle.
Here?
Yeah.
We are defining that in animal.
Public abstract string word, right?
Oh, here? Yeah. Oh, because here's the thing. It's, remember, when we... No, it's just define it there, but for us to be able to inherit that, we have to define in our own class. Even though it's abstract, if I don't define it here, that I promise that I'm gonna implement that, it's not gonna compile. I have to, again, I have two options. I can either do the true implementation here, or I call abstract, and I say, I'm not gonna implement this, I'm gonna let my children implement that for me. I promise that, again, my children will implement that for me.
Can you go up? Like what was this?
Yep. What is that? What? Yep.
I couldn't find the
It's the previous slide. It's the previous slide. It's here.
Next slide.
Yep.
Why in the animal class you have to define the measure gain? So you can just name it.
Why what?
In the animal class animal.
Yep.
Public abstract word.
Yep.
This one is already in the I workload that I inherit from.
Yeah, but I have to define it here to promise that my children must override that. Okay? Okay, so before we say our goodbyes, there is an exercise on this one. Please take the time to do them. If not, we're going to do that next class. Again, this topic will be there in our final exercise, midterm exercise, okay? I think that's it. Yeah. Yes. Again, if you come up with any questions, let me know. Otherwise, I'll see you next week, okay? A good one. What's up? Yep.
Question in exercise 5. So I have a question. So it is saying that I have.
Put it here, because otherwise.
So it is saying that I need to inherit. I mean, override this to string. It is a parent class. I already overriding, right? So then what?
Who's the parent class?
Photo.
A photo? Is it?
Yeah.
Scroll up.
But I'm inheriting. I'm overriding because it's object, right?
I get it.
Okay. Then what should I use here? Again, override.
Override again. If this will be overriding the behavior of the photo,
yeah.
you keep overriding. You keep using the override keyword.
Okay. And what's the reason to have a color here?
What is the reason?
Yeah, because it's saying use a color, but there is no any instruction how to use it.
Okay.
So we have made it photo class includes a string fields called a color, and that's it. And the frame class includes two strings called the frames material. The photo ID increases by 10.
Got it.
It's correct,
Yeah,
right?
yeah.
So I'm overriding the price.
Let me just see. Includes the string fields to hold
Yeah,
the
but
color.
this is another one. So this is this one.
Okay.
So it has to do this, and what should I do with them? Nothing? Just
Well,
leave them?
I guess so.
Okay, and then I need to use this to get override
To calculate the price.
Because my price is bigger, right?
Mm-hmm.
Okay. And I hope it will. Okay, so color I don't use because it's empty, and there is no instruction what to do with it. And then how I can see the price. So, for example, I mean, what should I do?
Well, you can call toString. I mean, you are putting the price into string, correct?
Yeah, I have photo, right? But I need to, for example, plus 10. So to see that this changed, I want to change.
So you have to call toString.
So I need to first, I think, method. So I have this, and I can use it, right?
Yep, you can call toString.
Oh yeah, I can. No, I still need.
Yeah, I mean, you have to set some values there, so you can experiment with.
Photo dot string, and then all this I need to comment out. That will not bother me. Then let's see. So it should be 399 plus 10. 8, 10. Oh.
Yeah, put a break. Put a break point there and go debug.
Okay.
I mean, you have to practice debugging.
Yeah, I already fixed one mistake by debugging.
Okay, so now fix the second one.
Yeah, I just want to check it.
Yes.
It will be like 3 Visual Studio questions. We'll do it like practice.
Will be an exercise in Visual Studio. Yes. Yep. Okay. Let's fix that. Let's fix that.
Tomorrow you don't have that. Sunday.
You too. You too. Okay. So let's see here. So groups. So right now, what's the situation? Who is where?
3 of them, one is absent, are in one group, and I am
Okay.
in
So which group?
5.
So group 5.
Yeah.
So we have 4 here in this group, correct?
No. Like in our system, it shows 3.
Okay. Oh, sorry. Sorry, it's wrong section. Wrong section. Okay. So you said group 5 again?
Yeah.
Okay, so 5.
I'm the only one in this.
You are the only one here. Okay, so here's what I'm gonna do.
Okay.
I'm gonna
just
take
add
you.
3 of them into this group because I've uploaded.
Are you already in another group?
Yeah.
Okay, so how about we use that group then?
It was 5, 1.
Okay, which group is that?
I think it's. Yeah, the first one.
Yeah.
I think so. Yeah, that one.
So here, uncheck this.
Yeah.
Who
So I
else?
think it's.
Basil here.
To this one.
What about?
But I've uploaded the
Yeah.
assignment.
He had uploaded
There.
it.
Okay, let's do one thing at a time. First, let's group you guys together. So which group will stay, which group will go?
We just add 3 of them into the group 5.
5.
Okay,
Yeah,
so
now-
this group, okay, so this group here,
Cancel this group and add us to like
Group
in
5.
group 5. Yeah.
okay, so this group will have nobody.
Yeah.
Okay. So group 5.
Yeah.
So
Think about
second one.
the second one.
the second one, okay, here,
Yeah. The basic.
basic,
Yeah,
okay,
that-
basic, okay. And then we have
That cut.
here.
Yeah, that one.
Okay, so how many? 1, 2, 3, 4. Bye. Have a good one. 4. That's
Yeah.
it.
Yeah.
Okay. Go in peace.
Thank you.
Thank you.
In the exam, we only one program.
Only it's enough just to upload one for on behalf of the entire group.
No, but the midterm test,
Oh yeah, sorry.
we have different questions, like different coding questions, or just one question including all
Well,
topics.
it's one question with A, B, C,
sub-pair.
D,
Okay.
E, F. Yeah, kind of. It might be.
In
It
5
might.
hours.
It might be. It might be one line. That's just that. It's one exercise.
And different parts, right?
Yes.
Okay.
And
Okay.
in the quiz that was that if the child class contains all the members of the base class, so I will run it false, but it's wrong. But
I don't remember the question right now.
the thing is that the private members of the base class, it is not accessible in the child class too.
That's right.
Mhm.
Yeah.
So
Again, I don't remember the question.
so it's wrong.
Uh,
so I got only 7 out of 8.
Oh, that's fine. That's fine. You still got a good grade there. Okay, so go home. Go home. Bye.
So, when you say to define by default a field, when I have to define by default in the field or inside the method?
Okay, so let's go to the properties. Let's go to the exercise there. Which one?
Let me see. Define Reese default value of $1,000 for base salary.
Okay,
For
so
all
for,
the
for that item there, you can define the default at the very top in the field.
Okay.
Yeah, that's one way. Or you could also define that in the constructor, but there is one of the constructors that you are already sending a value there. So my recommendation is that 1,000, put it there in the fields, you're going to be fine.
The other question is, there is no problem if I put just ID, name, inside of this, and don't put it in the main.
Correct, because you are, again, that's one of the items there that you need to initialize the constructor.
Yeah, without parameters, all the...
So again, in the context of constructor, the first one that has no parameter, initialize the instance data mirrors. That's it, that's what you did there.
Default value 0.
Whatever. When I say initialize, do whatever you want.
Okay.
It's up to you. It's up to you how you initialize them.
Okay.
Okay?
Okay. I think that's all.
Okay?
That's all. Yeah.
How's Fortaleza?
Very hot.
Very hot?
I can't handle anymore. I'm gonna ask my citizens, Canadian citizens, because there it's too hot.
Oh my, oh my.
It's just 4 days. The third one I want to go back. Jesus Christ.
There is an exercise about automobile, that is 8 automobile exercise. You can use the array with object. Yes?
Okay, ask that again.
It's one of the exercises is about automobile that
got it.
8 we assume that 8
8 items, 8 objects,
yes.
okay.
We can use this array of type.
If you know how to use an array and work well, that it could be.
It's very
Or-
in a loop we can set the value and get rid of it. So beautiful.
Okay. No problem.